Okay, so let's get right into it and talk about what we need to do to calculate these numbers of particles. So we're going to need a formula, and the formula is given here on this screen. It's fairly straightforward. These formulas are going to have three parts to them, and they're not going to be much more complicated than that. So the formula, we're going to say moles. So that's our new unit of counting, is going to be equal to the number of particles of whatever we have. So this could be carbon atoms or elephants or bouncy balls or electrons of hydrogen around a hydrogen atom. We're going to say the number of particles, and then we're going to divide that by Avogadro's number. And so it's just like I did with the donuts example, right? We have 36 donuts divided by how many donuts in a dozen, and we end up with the number 3 dozen. So we're doing the same thing here, just taking the number of particles, dividing it by Avogadro's number, and telling me how many moles there are. Now, there is probably an easier way. I might suggest you write these down. You might want to, because sometimes we'll have to rearrange this formula. And if rearranging formulas is not something you enjoy doing, then do this little trick. I'm going to put this formula into a triangle. The triangle has 3 sections. And what I'm going to do is put the word moles right here. I'm going to put number of particles up here, number of particles, and I'm just going to put a number, Avogadro's number down here. Okay? And whenever I need to get a formula, if I have this triangle in front of me, which if we were in class, these would be up on the wall, I just look at the one that I'm trying to use. Let me just cover up one of these. So I'll cover up one of the ones that I want to find in my formula. Color that orange. So if I want to find moles, I cover up moles, and I see that it's a number of particles, and it's over, so it's divided by Avogadro's number, exactly what we wrote right here. If I would like to find the number of particles, then I could write a new formula, simply by covering up the one that I want, so the number of particles. I can now write number of particles equals, and the bottom two things are beside each other, so they multiply. So moles times Avogadro's number, and we have a new formula. So there's no need to rearrange if you don't want to. You can just use this triangle and keep this with you so you have something to use. And then if we go for the last formula, if we want to find Avogadro's number, which we don't usually do, but if we wanted to use the formula to check Avogadro's number, then we would say that Avogadro's number, which is the one we're looking for, is equal to the number of particles divided by, because they're on top of each other, divided by the moles. Okay? So we can generate 3 different formulas by remembering this triangle. And then that way you have all of the possibilities to solve all the different questions that I might ask. But the base formula would be this one: moles equals number of particles over Avogadro's number. Okay? So that's our first number relationship. That's the first thing we're going to deal with from a calculation point of view. So let's give it a try and see what it looks like. So the first question that we might be asked is to say how many molecules are in 0.67 moles of water. So 0.67 moles of water, that's less than 1 mole. So we know that there has to be at least a 6.02 times 10 to the 23rd particles will be in 1 mole. This is how much is going to be in about 2/3 of a mole. So let's just figure this out. Now I'm going to go through the whole process of a calculation. As we get more complicated, you'll want to do all these steps, but it may seem a little bit simple at this point. So I'm going to put down my data statement saying that I'm not trying to find moles. I know moles, so I'm going to write my number in there. And it's 0.67 moles. And if I'm talking about number of molecules, okay, so number, that's just a kind of particle. So I'm going to write number of molecules. That's what I'm trying to find. I usually put a question mark in there. And we know something about molecules and moles. We know Avogadro's number. So Avogadro's number, equals 6.02 times 10 to the 23rd particles, or in this case, molecules, right? So it's 6.02 times 10 to the 23rd. So now if we want to figure this out, we go back and we grab our relationship that we need. So if we go back over here and we look at this, what we were doing, let me just bring this triangle over. So there's our triangle again. So since we're trying to find molecules right here, we're going to use the formula written in this form. So let me just get this written down. Number of molecules, so that's number of particles, the one on the top, number of molecules is equal to the number of moles times Avogadro's number. And then if we substitute in, well, the moles is 0.67 moles. Avogadro's number is that one we have to remember, 6.02 times 10 to the 23rd molecules. And when we multiply those two things together, we'll get our answer. 0.67 times 6.02 times 10 to the 23rd. Now, I will put another little video up showing you how to type that into a calculator. So just if you have trouble typing in 6.02 times 10 to the 23rd, I'll put a quick video up showing you how to do that. But the answer here would come out to be 4, and we're trying to do about the same number of decimals that's in our question. So we'll go 4.03 times 10 to the 23rd molecules. Okay, so that kind of makes sense. It would be 6.02 times 10 to the 23rd in 1 mole. And since we're only looking at 0.67 moles, it should be a little bit less, 4.03 times 10 to the 23rd molecules. Okay, so when we do a question, that's what I look for. I look for a data statement. I look for you to state the formula and substitute your numbers in, and then solve it. Okay. All right. I'm going to try one more. So let's say we had some mercury, and we have 2.5 times 10 to the 15th atoms of mercury. So how many? Find the amount is this. So amount, whenever you see that in a question, in a chemistry question anyway, means moles. So whenever a chemist asks you for the amount of something, they want moles. If they want the volume, they'll ask you for the volume. If they want the mass, they'll ask you for the mass. The amount refers to the number of moles. So let's go through this question again, just like we just did the last one, and see what we can come up with. So the first thing we need is our data. So we have a number of atoms, this time since we're talking about mercury. That's equal to 2.5 times 10 to the 15th atoms. Okay? And we would like to know the amount. So we're being asked to find the moles of mercury. So that's going to be our question mark. And we need to know Avogadro's number. Avogadro's number never changes. It's always the same. 6.02 times 10 to the 23rd atoms. Okay? And let's just grab our formula again. So I've got this triangle. I'll pull it down here where we can see it. And this time we're looking for moles. So we're looking for this box. So that's particles divided by Avogadro's number. So again, let's write that out. Let's see, mole equals number of particles divided by Avogadro's number equals, number of particles was 2.5 times 10 to the 15th atoms. And we're going to divide that by the number of atoms in a mole. which is Avogadro's number, 6.02 times 10 to the 23rd for Avogadro's number. And again, if we calculate this out, we end up with a fairly small number of moles. So it's 4.15, just keeping a couple of decimals, times 10 to the minus 9 times 10 to the minus 9 moles. Okay, so it's just a small part of a mole. That makes sense. We have way less than 10 to the 23 here, and so it should be smaller. It should be less than 1, and it is 4.15 times 10 to the minus 9 moles of mercury atoms. Okay, so that's the kind of question we're going to start out with using this formula, using this relationship, moles equals particles over Avogadro's number. And I'll post some questions that you can practice just using that part of the formula. And then we'll kind of add things to this as we move along. We haven't put the word mass in here. We haven't put the word volume in here yet. So in the future, we'll be looking at masses and volumes. But for now, let's just get familiar with being able to, one, type in these great big long numbers. So I'll put a video up that shows you how to type in 2.5 times 10 to the minus 15 in your calculator. And then being able to kind of manipulate the formula. So that's our first bit of practice. So I will put a worksheet up for that later on today, and you can give that a try. And then we'll move forward in another day or so to the next use of the formula. Okay. So here's one last one. You might want to just pause the video for a minute, and you can try this one. It says, how many atoms of oxygen are in 3.52 moles of carbon dioxide? So pause your video for a minute. See if you can figure that one out, and then come back and take a look at my answer. Okay, and welcome back. Again, we could write this one all out. Let's just do our work here. So we know the number of moles. So that's 3.52 moles. And we know Avogadro's number. That's something we can always write down. We need at least two of the three things. So that's 6.02 times 10 to the 23rd. And we want to know how many atoms are in those moles. So then we're trying to find atoms of oxygen. So the formula again, this time we will use, we're trying to find number of atoms. So number of atoms, if we check our formula triangle, number of atoms is equal to the moles times Avogadro's number. And so we've got 3.52 times 6.02 times 10 to the 23rd. And if we look at that, we end up with a number of 2.12 times 10 to the 24th. Now, what's our unit here? We have to be careful because it says atoms of oxygen are in moles of carbon dioxide. So what I've got here is the number of carbon dioxide molecules. So this is CO2 molecules, right? Because it's 3.52 moles of carbon dioxide. So this first number, 2.12 times 10 to the 24th, is the number of molecules of carbon dioxide. But I want atoms of oxygen. So we need to do a little bit of a change here. So just to make a little more sense, I'm going to put number, cross that out. I'm going to put that we've calculated CO2 here. So the number of CO2s. Now we need to get the number of oxygens. Well, if we look at it, there's 2 oxygens in every CO2 molecule. So 2 times the number of CO2s will give us the number of oxygen atoms. So that's just 2 times 2.12 times 10 to the 24th and equals, so 4.24 times times 10 to the 24th oxygen atoms. Yeah, so be very careful there. When we look at this one, we've got a little bit of a trick. We weren't actually finding the atoms to start because we're given it 3.52 moles of carbon dioxide. So the first thing we found was the number of carbon dioxide molecules. And then once we had that, we could find the number of oxygen atoms inside that number of carbon dioxide molecules. Okay, so it was a two-step process. And it requires you to remember all the stuff about molecules and what they look like and be able to write their formulas and then work through a question here with atoms. Okay, so we'll leave it there. I'll post some practice and please respond with any questions you have. Thanks.